All right, we are looking at lesson 6.6 in your algebra book, equations for lines through 2 points. We're going to continue our work with the point-slope form equation, y minus y1 equals m, which is the slope, times x minus x1, where if we have the slope and we have a point, we can plug in for x1 and y1, and we also learned how to rearrange that in the slope-intercept form, which is usually a more useful form for us putting things on a graph and finding different information about. So today, what's different is we're going to be looking at this big idea. An equation for the line through any 2 given points can be determined by first calculating the slope of the line. So we'll talk more about that in a second. If you look, we're going to be given 2 points, and that's it. And then they're going to ask us to write the equation for the line that goes through those 2 points. So if you think about plugging into this equation, well, we've got 2 points, and when we actually go to plug into our equation, it does not matter which one you use. Any point that's on the line will work. So since both of these are going to have to be on the line that we're looking at, you can use either one of those to plug in, so the 6 and the 9, or the 2 and the 7. But we also need a slope, and that's not given to us here. Okay, so our very first goal is going to be to find the slope. And students always quickly forget what we've been doing. So when I say find the slope, you go, how do you do that? y2 minus y1, x2 minus x1. Change in y, change in x. And everybody says, oh yeah. Okay, so if you have 2 points, you can very easily find the slope with this formula. Once you've got the slope, you can now just plug in to the equation. And like I just said, you can use either point to do so. So you're going to have 2 points. You can use either one as your x1 and y1. And then 3, we're going to continue always finishing this off by solving for y, which puts it into the slope-intercept form. Much more useful piece of information for us moving forward. All right, so if we look at example number 1, we're just going to run through these steps. Pretty straightforward. All skills that we've already mastered. Now we're just putting them all together. So first things first, we need to find the slope here. We can't write an equation without the slope. So we're going back to our slope formula. Subtract your y's, 7 minus 9. Subtract your x's in the same order, 2 minus 6. And of course, you could have gone the other way, 9 minus 7 and 6 minus 2. So I get negative 2 over negative 4. 2 negatives means my answer is actually positive, and 2/4 simplifies to 1/2. Okay, so now I can write my equation. This is my slope, and I can choose either one of these points. So I'm going to plug into the formula y minus y1 equals slope x minus x1. Again, either one of these is fine. I can't stress that enough. I'm going to use 6, 9 just because it's first. So x1 comma y1 for me is going to equal 6 and 9. But if you use 2 and 7, it will actually simplify to the same y equals mx plus b. All right, let's change colors here. Plugging in. Plugging in for y, it's positive 9. So I'm going to say y minus 9. My slope is 1/2. And this is just like yesterday's work now. X minus my x1, which is 6. And we talked yesterday, the formula says minus. So when you put in a positive, it doesn't change that. It stays minus. So positive numbers will always have a minus in front of them when you're plugging in for x1 and y1. Negatives will change them. All we have to do now is simplify and rearrange, solve for y. So first thing we're going to do is we're going to distribute. So I'm going to leave y minus 9 alone. 1/2 times x is just 1/2 x. And 1/2 times a negative 6 is a negative. 1/2 of 6, 3. Nice and easy. Almost done. Get y by itself. So we're going to add 9 to both sides. Now it's in that y equals mx plus b form. Still have 1/2 x. And think about why that makes sense. We already figured out the slope was 1/2. So in this equation, the slope spot is 1/2. And in my y equals mx plus b, which over here is going to be a plus 6, I also have a slope of 1/2. So again, m equals 1/2, which it always should match. But now we have more information. We have b equals 6, which tells us that on a graph, this line, even in this form, these are equivalent, will hit the y-axis at 6. So let's try one more just straightforward like that, and then we'll take a look at how this shows up in a word problem form on the back. So first things first, finding the slope. Can't write an equation without the slope. Not given to us, but we can find it with 2 points. So subtracting your y's, 20 minus -4. Subtract your x's, 18 minus 10. So minus a negative goes plus plus, that's 24. 18 minus 10 is 8. 24 divided by 8 is 3. Okay, so m equals 3. Now, again, you can use either one of these, and I think there's a clear choice here. Since this one has a negative, that tends to be where we make silly mistakes, right? Is plugging in negatives. If you have the option and one has 2 positives and one has any negatives at all, go ahead and choose the 2 positives. So my x1 and y1 that I'm going to use in this problem is 18 and 20. But again, I can't stress enough, if you plug in 10 and -4, you're still going to get the same answer. It's going to work. All right, so now plugging into the equation, oops, keep doing that, y minus y1 equals mx minus x1. So my y is 20, so I'm going to write minus 20. My slope is 3, and my x is 18. I'm going to simplify now. So leave this side alone for a second. Distribute 3x minus 54. Now we're going to add the 20. Y equals 3x minus 34. We're in y equals mx plus b form. So from this information, we know m is 3. Again, that shouldn't change. This line is always going to have the same slope. But now we also have more information. Not only do we have 2 points, we actually have 3 points now. We know the point where this crosses the y-axis. So remember, this point actually represents 0, -34, because that's the point it hits the y-axis. And just to reinforce that again, if this down here was the y-intercept, slope of 3, this line could look like this. This point right here would be 0, -34. And then 10, -4 could be here. And 18, 20 would be up here somewhere. So all 3 of these points are on that line. This one is very specific. It's where it hits the y-axis. All right, going to the back. We got a hot air balloon. It's resting on a platform. It begins its ascent, which means it's rising. It's 175 feet above the ground after 3 minutes, and 275 feet above the ground after 5 minutes. Those are 2 different sets of information. We're going to assume there's a constant rate of ascent. So when graphed, if we looked at the ascent, it's going to be a straight line. Okay, if it wasn't, then we don't have enough information to solve this. So constant rate is going to form a straight line, meaning it's going to have a slope. Okay, so this will be a straight line and we can handle that. So it says express the information above as 2 ordered pairs. We have 2 different sets of information. We know that it was 175 feet above the ground after 3 minutes and 275 feet above the ground after 5 minutes. 2 different sets of information. So when we go to set that up, we are going to write that as, now you kind of have a choice which way you want to do it. You could put the feet above as your y, and you could put the 3 as your x, or you could do it the other way around. For this case, if I think about this as a graph, I'm usually going to put my time on the bottom and watch this rise. So if I went over to 3 minutes, I could see it at 175. And if I went over to 5 minutes, I could see it at 275. And I could watch this line climb up the graph. So because of that, this is my x, and this should be time. So when I go ahead and I make my x and y coordinates, I'm going to use the minutes or the time as my x, and I'm going to use the height as my y. So my first point is 3, 175, and my other ordered pair then would be 5, 275.